Reactivity of amines. Amines generally behave as bases. This can be seen from their pKa values. For example, the pKa value of methylamine is 40, which tells us that this is a strong base. When compared to amines, the protonated amines are relatively acidic. This can also be seen from their pKa values. For example, the anilinium ion has a pKa value of 4.58, which tells us that this is acidic. Because of the lone pair of electrons present on nitrogen, amines can act as bases and as well as nucleophile. Here are some situations where amines are acting as nucleophile. Here, these lone pair of electrons that is present on nitrogen is going to make a nucleophilic attack on this electrophilic carbon, thrusting the electrons onto bromine for it to leave. Right? So it can take part in nucleophilic substitution reaction. Here is one more example where an epoxide has been converted into an alcohol, where here again this amine is acting as a nucleophile, opening the oxidane ring structure. Here are the pK values of some protonated amines, and you can see from here that the anilinium ion is the strongest acid in all of these. Why should an anilinium ion be strongly acidic? What is the reason behind it? Let's draw the structure of the conjugate base. Here is the structure of the conjugate base, and you can see here that nitrogen has got its lone pair of electrons, and these lone pairs are going to be involved in delocalization, and because of which this conjugate base is really stable. Now if the conjugate base is stable, the acid that it started from should be strong, and that is the reason why anilinium ion is a very strong acid. And here is an example where amine is reacting as a base, where these electrons from the nitrogen is going and abstracting this hydrogen, thrusting these electrons onto bromine, so it can form the protonated amine. So this one right here is amine acting as a base. Here is the relative reactivities of compounds with the electronegative groups that is attached to sp3 carbons. We have alkyl halides, alcohols, ethers, and amines. Now between all of these compounds, we can definitely tell that amines are the ones that is least reactive. Why? Because it has got a very strongly basic leaving group. When we take an alkyl halide, the leaving group here is halide ion. Halide ion is weakly basic, and this can also be seen from the pK value of its conjugate acid. So if this is going to be a strong acid, definitely F- should be a weak base. When compared to amines, all of these groups right here are weakly basic and are better leaving groups. And that is one of the reasons why amines do not undergo any substitution or elimination reactions. Here are some of the important reactions of amines. Amines can take part in nucleophilic substitution reactions where they themselves are not going to act as a substrate. Instead, they are going to act as a nucleophile. Here is a nucleophilic substitution happening between alkyl halide and amine, where you can see that amine is acting as a nucleophile attacking the electrophilic carbon. Amines can also take part in nucleophilic addition elimination reaction. Here is an example for the nucleophilic addition elimination reaction happening between acyl chloride and two equivalents of the amine. Here, one equivalent is used as a nucleophile and the other equivalent is used as a base. Primary and secondary amines can react with carbonyl compounds to form imines and enamines. Amines can also take part in conjugate addition, also called as the 1,4 addition. Here, the amine nucleophile will go and attack the beta carbon of the alpha-beta unsaturated carbonyl compound. Here is an example for an alpha-beta unsaturated carbonyl compound. This carbon is electrophilic. This beta carbon is electrophilic, and therefore the amine can act as a nucleophile attacking this electrophilic carbon, producing the 1,4 addition product. Amines can also be used in the formation of diazonium salts, and these diazonium salts can later be converted into other useful compounds by reacting it with nucleophile.